Hello, this is Ganjbakhsh. I'm here to present my paper named Weekly Supervised Learning in a Group of Learner with Communication for ICCKE 2022. Okay, here's the content. First of all, problem definition. Then we are go into proposed method, and for the third step, we see the result, and finally the references. Okay, problem definition. Today, supervised learning can be performed on various tasks from object detection to very complicated tasks in medical images. It is obvious that the efficiency of these models depends on the amount and quality of training data. As we know, preparing collecting and labeling is not easy work. In, uh, in some particular cases, like beginning of the corona pandemic, uh, there was not enough data available for collecting or even uh, for labeling. So weak supervision methods come up for overcoming the lack of uh, data for training. According to the reference tree, the weak supervision can be divided into three types. First, inexact supervision. Second, inaccurate supervision. And third one, incomplete supervision. About inexact supervision, I can say when the coarse-grained labels are given. For inaccurate supervision, I can say uh, when the labels are noisy, and for incomplete supervision, I can say only a small subset of data has label. We are focusing on the last branch. This branch has four main sub-branch named generative methods, graph-based methods, low-density separation, and disagreement-based methods. For the first one, these methods assume that the same model is used for generation of labeled and unlabeled data. So unavailable labels may be treated as a missing parameter of such generative model. Iterative methods like EM can be used for obtaining the missing labels. For the graph-based methods, these methods try to construct the graphs on a data instances. The label information is then propagated on the graph based on selected measure of similarity, which denotes the edge weight. Problem can be solved by finding proper minimum cuts that separate region of similar labels. A drawback of this approach is when the new data is coming, the graph structure must be reconstructed. And for last one, for the third type, uh, this branch applies classifier boundaries in less dense region of input space. The most famous is S3VM, semi-supervised support vector machine. In this method, problem usually formulated by searching through different hypothetical labels for unlabeled data. And finally, for the last one, disaggregate methods. In a cooperative learning framework, they train multiple learners, then let them judge about unlabeled data. A good example for this is a reference 13, where after co-training two classifiers with dissimilar feature sets used to obtain label of unlabeled data. We are in this category, but we use the same feature set for co-training, and it's because of problem limitation about labeled data. Okay, we are going to proposed method. Consider a network of learners. They have same feature sets. because of shared history or lack of proper data, small data for training, learner can be correlated to each other. So learner need in this stage need to label data and train labels for getting close and close to the real situation like social networks. Some methods like Raycar try to did not consider the communication between learners, and after a large batch of opinions of learners about unlabeled data, try to extract real label data, real label for data. But if the network was very large, what happens? We cannot gather all data unless with the cost of collection. Uh, and also, if the network was very big, we cannot even process the whole uh, bunch of opinions. So the first idea is the process data as it is distributed. So the learner can collect information from its communication on the graph. Consider this network. Okay, as I said, process of processing data as it is distributed. What about correlation? How we can involve it to calculation? According to the paper of multivariate Bernoulli distribution, the independence of two learners in a graph is equivalent to the non-correlation of two nodes. So we use this and consider only pairwise dependence. Here's the scenario for each unlabeled data. Each node asks its neighbors to label it. Let's consider node 7 in the graph. And if we remove the edge from node 7 to its neighbors, we reach to this picture. If we look closely, there are several components which are independent. I mean, there is no edge between them. Now, if we are able to get each component opinion about the unlabeled data, with considering correlation between them, we can use any methods like Raycar or any aggregation method for getting the real label. But how? If we see this network, it is like Markov network. In Markov network, by iterative methods, we can estimate these parameters of network. If we run inference on the Markov network, we can estimate correlation between them. So with the probabilistic inference in the form of maximum likelihood, the opinions of each component can be obtained, and inference after we collect that opinions of each component, we can pass them to the Raycar or any aggregation method. So learners of network, we can after getting the right or processed label for unlabeled data, we can use that label for growth of learners. So we're using that labels for training each node in the network. So this is a proposed method. We are going to the result part. There is some notes about implementation setting. We take the graph structure as an input, and we use MNIST database for evaluation in 2 class and 10 class. The initial population accuracy is 30%. Here is the 3 methods that we use them in experiences. The first one, the training the population without considering the growth of learners and their correlation. Second one, the training of the population along with modeling the growth of learners. And the third one is our proposed method that considered learner growth and their correlation between them. Here is the result in the in 2 classes and by using MNIST. As it is clear, our proposed method is very better than the others. Even in the first iteration, and here's the test of final. Here's the result of test in the final test. Here's the result of modeling the growth of learners, and here's the growth of learners without with correlation. And as it is clear, we are far better than the method 2. In MNIST 10 classes, we just put them in the experience method 1 and 3. Excuse me, in this 10 classes we only used methods 2 and 3. We did not consider the method 1 because it's not that was not very good. As it is clear, we are very in a good place. Again, we are very far better than the method 2. And if I'm take a close look at the RACAR result, if it's considered all individual nodes independent for two classes and 10 classes, 66% and 69%. Both of them are very low than our final results. If we consider the timing of the all process of training, we see the local recall plus correlation and learning. It's for all process is 1 to 10 of the global recall. And for the 10 classes, it's rises about 1 to 20. What I'm trying to say, if it's growing and growing, global record cannot be done for the real networks. Okay, here's the references, and thank you.